After Starship Flight 11, the FAA has officially confirmed SpaceX's next milestone, a full tower catch for Starship. This isn't theory, it's documented in the latest AI report outlining the approved landing trajectory back to Starbase. If successful, SpaceX will achieve the first fully reusable, super heavy spacecraft in history, cutting costs, boosting frequency, and rewriting how we reach space. Let's dive right in. For over half a century, rockets were built to fly once and die forever. NASA, Russia, China, they all tried, but no one could master true reusability. Then came SpaceX. Falcon 9 changed everything. It proved that a rocket could return, land, and fly again, cutting launch costs by more than 90%. But Elon Musk never wanted partial success. His vision went far beyond landing boosters. He wanted a fully reusable spacecraft, capable of carrying 100 tons to orbit and coming back safely, ready for another flight. That dream is Starship, yet one brutal problem remained. Starship is colossal. It's taller than the Statue of Liberty and over 5,000 tons when fueled. And unlike Falcon 9, it has no landing legs. So how can SpaceX land a falling skyscraper? Safely, precisely, and fast enough to reuse it? That's the question that pushed Musk and his engineers to invent something no one else dared to attempt. Just after Flight 11, the FAA quietly released a report that stunned the aerospace community. For the first time, regulators officially acknowledged SpaceX's plan to catch Starship with Mechazilla's giant arms, a real move toward full return to launch site recovery. The document outlined a detailed landing trajectory. Starship would re-enter over the Pacific Ocean, glide across northern Mexico, pass near major cities like Hermosillo and Monterrey, and finally slow to vertical descent as it approached Starbase, Texas. And instead of falling into the ocean, it would be caught mid-air. This isn't a fantasy. It's the first time the FAA has signaled approval for SpaceX to attempt a tower landing with both the booster and the upper stage. It's also proof that the company's data from Flight 10 and 11 convinced regulators that this might actually work. But what exactly gave the FAA enough confidence to let SpaceX proceed? Musk calls it dynamic catch synchronization. It's not just a landing technique, it's a new kind of flight control philosophy. Starship and Mechazilla don't act independently. They communicate through a real-time predictive algorithm that anticipates motion milliseconds ahead. Every atmospheric change, every thrust variation, every crosswind is processed instantly. The tower adjusts its arm position before Starship even arrives. Inside SpaceX, engineers refer to this as Catch AI. It uses neural networks trained on thousands of flight simulations, telemetry from previous tests, and live feedback from Raptor engine data. The system doesn't just react, it learns. If it works, the tower becomes a living extension of the rocket itself, an intelligent partner instead of passive infrastructure. And the benefit goes far beyond the spectacle. It could make rapid reuse a reality. Imagine Starship landing in the morning, refueled by night, and launching again the next day. That's Musk's ultimate goal, turning rockets into airplanes. Now let's talk about why this matters. A single Starship stack, including booster, ship, and engines, costs around $200 million to build. But if it's recovered and reused, that price could drop to under $10 million per launch. That's not just cheaper, it's revolutionary. No nation, not even China, can match that efficiency. NASA's SLS, which costs over $2 billion per flight, becomes instantly outdated. By achieving full reusability, SpaceX would slash the cost of putting 1 kilogram into orbit from $60,000 with the space shuttle down to just $67 per kilogram. That's a 1,000-fold leap in human progress. And it's not just about saving money. Lower costs mean faster testing, more launches, more data, and faster progress toward Mars. But first, SpaceX must prove it can land Starship safely back at home. That's where things get complicated. Starship's approved flight path runs directly over northern Mexico, one of the most densely populated air corridors in North America. Cities like Monterrey and Hermosillo sit right beneath the re-entry zone. According to the FAA, Each Starship return could disrupt 100 to 200 commercial flights, affecting thousands of passengers for up to an hour. It's not just a technical challenge anymore. It's geopolitical. Mexico's aviation authorities will have to coordinate with SpaceX and the FAA for airspace management every time Starship comes home. That level of cross-border cooperation is unprecedented. Critics argue it's too risky. Supporters say it's a necessary step toward reusable rocketry. And here's where Musk's strategy shines again. SpaceX offered to share real-time telemetry with Mexican regulators, proving its confidence in safety and precision. This isn't reckless. It's calculated evolution. It's easy to forget how far SpaceX has come. The early days of Starship testing were chaos. SN8, SN9, SN10, one explosion after another. Each failure drew headlines mocking Musk's dream. But inside SpaceX, every destroyed prototype was a lesson. They learned how methane behaves under stress. They discovered that flap control must be fine-tuned in microseconds. They rewrote the code that now powers the reentry algorithm. By Flight 11, those lessons paid off. The booster's hover was near perfect. The descent profile matched simulation data within 2%. Even after minor damage to heat shield tiles, Starship stayed stable during re-entry and executed a controlled splashdown. It wasn't flawless, but it proved control, endurance, and precision. And that's exactly what the FAA needed to see. Behind all this progress is SpaceX's most advanced creation yet, the Raptor Phi 3 engine. This version is smaller, more powerful, and far more efficient than any rocket engine before it. Raptor Phi 3 operates at over 330 bar of chamber pressure, higher than any engine in history. It uses a full-flow staged combustion cycle, meaning every molecule of methane and oxygen is utilized. That translates to massive thrust with minimal waste. More importantly, the new design simplifies maintenance. Each Raptor can be replaced within hours thanks to modular architecture and 80% 3D printed components. That's how SpaceX plans to make Starship ready for flight every 24 hours. A goal no other aerospace company has dared to set. Raptor Phi 3 isn't just an engine. It's the key to the entire system. It's what allows Catch AI to precisely predict landing behavior based on live thrust data. So why take such a massive risk with a tower catch? Because splashdowns destroy value. Salt water ruins engines, corrodes electronics, and adds months of refurbishment time. Every ocean landing delays progress. A tower catch eliminates that entirely. The moment Starship is caught, it's back on the pad, ready for inspection, refueling, and relaunch. As Musk told his engineers, every day a rocket sits waiting for repair is a day Mars slips further away. That's the core philosophy driving SpaceX. Speed through iteration. They're not just building rockets, they're building momentum. Here's the detail most people missed. The FAA approval doesn't just cover Starbase. It also lays the groundwork for a second Mechazilla tower at Cape Canaveral. That means future Starship flights could operate simultaneously from Texas and Florida. One for commercial payloads, one for NASA's Artemis missions. It's the next step in creating a true interplanetary launch network. Imagine 2 Starships launching and landing in the same week. One bound for lunar orbit, another for Mars cargo prep. That's not science fiction. It's the roadmap SpaceX is quietly building right now. Of course, SpaceX isn't alone anymore. Stoke Space, founded by ex-Blue Origin engineers, is developing its own fully reusable rocket, Nova. With over $1 billion in funding, it's aiming to become the mini Starship of medium-lift rockets. Blue Origin's New Glenn and China's Long March 10 are also racing to catch up. But there's one crucial difference: iteration speed. SpaceX doesn't wait for perfection. It tests, fails, learns, and repeats faster than anyone. That's what gives it an almost unfair advantage. While other companies are still drafting blueprints, SpaceX is already analyzing real flight data, improving engines, and building new prototypes. That's why this great solution, the Tower Catch system, is not just another test. It's a statement that SpaceX is already playing in a future others haven't reached. All indicators point toward one historic moment: the first Starship tower landing attempt before the end of this year. If it succeeds, it will mark the dawn of the fully reusable era, a milestone equivalent to the Wright brothers' first flight. From there, Musk's roadmap accelerates dramatically. Orbital refueling, Mars cargo deployment, and lunar transport all become economically feasible. Starship will no longer be an experiment. It will be infrastructure. And once SpaceX perfects that, the implications ripple far beyond space. Cheap, reusable access to orbit will reshape communication, energy, and even defense industries worldwide. Still, there's room for doubt, and that's what makes this story real. Can Mechazilla truly catch a 5,000-ton vehicle without structural failure? Can AI anticipate turbulence in chaotic upper atmospheric conditions? And how will regulators react when those first catches start happening over populated regions? These are the questions SpaceX is racing to answer. Not with words, but with data. And whether you admire or criticize Elon Musk, one thing is undeniable. He's forcing the entire world to think differently about what's possible. So as we stand on the edge of this new chapter in spaceflight, one truth remains. This isn't just SpaceX's challenge anymore. It's humanity's. And this is exactly why the FAA's approval marks a true turning point. SpaceX is now closer than ever to full reusability. If Starship can return home and be caught midair, we're witnessing the moment space travel shifts from experimental to operational. What this means is clear: cheaper launches, faster missions, and a new era of exploration for everyone. This is the kind of innovation that will shape every future journey to the moon, Mars, and beyond. Not someday, but soon. If you found this breakdown valuable, give this video a like, share your thoughts in the comments, and subscribe to Space Hub for more real, data-driven insights into the future of spaceflight. Don't forget to turn on the notification bell so you never miss the next major breakthrough. This is Space Hub, where knowledge meets the future of space.